All right, topic 6 is the next topic that we have here. It's on appropriate sampling. Really, it's just talking about biases and different types of ways you would sample. But what are we going to learn here? So we're going to talk about the difference between a population and a sample. What are the different biases that can come up when creating a sample? What are the different sampling techniques that you can use to create a sample? These are the things we're going to look at. So, what's the difference between the population and the sample? Well, the population is basically the whole group, usually a large amount of people. Um, we'll talk about, well, let me define everything. We'll throw some examples real fast. Any piece of information that pertains to a population is called a parameter. So the way you want to memorize this is that it's P for P. Parameters go with population. And when we're talking about pieces of information that go with this, we're talking about things like means or averages, medians, any piece of statistical data that we can get that pertains to specifically the population is called a parameter. And then we're going to switch to what's called the sample. Sample is part of the group, something that should be representative of the entire population. And any piece of information that pertains to a sample is called a statistic. Again, S's. So statistic goes with sample. So P goes with P, S goes with S. And again, these are things like means, medians, and anything. And really, they can have different symbols too. So, like the population mean is mu, and the sample mean is x bar. The individuals in the sample or population are called the subjects. These are the individual things. Again, they don't have to be like humans or anything. They can just be anything that you are talking about in that sample itself. When taking information, we shouldn't take it from a total population. Basically, censuses don't work, especially 10-year censuses. Sorry, government, they really don't work that well. Even though we're forced to do them, they're really not that good. Okay, so that's the brass tacks. Now, when we think about this, is population could be like the U.S. and a sample might be like 10,000 people in the U.S. So you got the U.S. is the big population. 10,000 people would be the sample. You wouldn't want to do the entire population of the U.S. That would be unruly, and you wouldn't be able to really do anything too much with it. Really, if you're using the sample, well, then I'll talk about this a little bit later down the course. If you got a good enough sample, it should be approximating the population. All right, so determine what something is when something is a parameter versus when it's a statistic. So remember, if it's a parameter, it's based off a population, and if it's a statistic, it's based off of a sample. And really, the biggest way to figure out if something is a sample or a population is it general or is it specific? Populations are general, and samples are statistics. For instance, among men, the average height is about 5 foot 10 inches. It says among men, that's very general. It's a general group of men. So this would be a parameter. For 700 people, the average GPA is 3.0. So among men, men was very general. So that is a population. Specifically 700 students, that is a statistic. We're basing off of those 700 people. So this would be a statistic. The median amount of coffee drinks consumed per day by people in the age group of 20 to 29 is 3 cups. You might be saying that, well, that is a specific age range, but it's not a specific number of people. Therefore, the age group of 20 to 29 is still a population. So this is going to be a parameter. For it to be a statistic, you need to have like a specific number of people. The standard deviation of weight in young children is 20 pounds. Again, we're just talking about young children. We're not talking about 500 young children. So that would mean that this, once again, is a parameter. 300 adults report that their average car insurance is $200 a month. We're talking specifically about 300 adults, so that is a specific thing. So it is statistical. It's a statistic. And then taken from 800 cups of soda, the average amount of sodium was 18 ounces. So that's also a statistic because we're talking about a specific 800 cups of coffee, not generally from soda. Okay, so that's the difference between population and sample. What are some problems with taking samples? Samples should be representative of the total population. What can make this hard? Bias. Bias is that thing that they try to weed out when you're trying to go into jury duty. That's why they ask you questions to get rid of bias in that thing. It's basically having some kind of predetermined or predisposed what's the word I'm searching for? Some kind of predisposed notion against what you're doing. So what are some different types of biases when we're talking about our actual sampling stuff? Well, we have what's called sampling bias. It's when sampling doesn't appropriately represent the population, which is something you would do purposely. It's kind of like if you're watching this, you gotta try to think of a general one for anybody who might be watching this. If you were to go to, let's say you were to go to Mexico, and most of your people that you pick were Caucasian, that would not be representative of the population of people in Mexico because they're mostly Latino. So that would be a sampling bias because it's not representative of what's going on in that particular country. And honestly, in that case, you would have to be really attempting to not get that thing right. You're doing something on your end that prevents it from actually happening. Then you have what's called a non-response bias, and people choose not to respond, or at least not enough people. So theoretically, all of this should be random. We'll talk about this later. So you pick people at random, you give them some kind of questionnaire, some kind of something, and they just don't respond. That's considered a bias because you want as many people to respond. That can lead back to a sampling bias because you're not getting the appropriate representation of that sample. You can have response bias where people lie in their response. I am a teacher of high school students, and every now and again they do make them take these weird surveys where they're kind of health related. They act about the practices and stuff, and sometimes they will talk about their drug use on the weekends, and of course no one's ever going to be honest about that. So I really don't know why, especially high school students. I don't know why people ask high school students about their drug usage when they're just giving a general survey because they're never going to tell the truth. But I had a kid who I had to give the survey out to a group of seniors, and after they turned everything in and I gave it to the person, and I did what I was supposed to. I didn't look at any of the answers. I didn't do anything. He comes up to me and says, "Hey, I just want you to know there's a question on there about how much cocaine we did on the weekend." And I told them that I did about 2 rocks every weekend. And I was like, why would you do that? We all know you don't do drugs. And he was like, oh, it's just funnier that way, kind of tainting the results. So that would be a response bias. And you have what's called a voluntary bias. You always get people who volunteer. It's always the same people. You may not think that should be a bias, but it is because people who volunteer are always are always the same people. You can kind of think of this as like political polls. The people who volunteer for political polls are usually the people who lean towards one direction, or the people who would, if you have a particular website that's leaning one direction, you're gonna have people of that direction coming up. That's why you really shouldn't put a lot of faith in polls. You kind of saw this in one of the elections, um, where polls said one thing and the outcome was totally different. Uh, Polls are they're not great. They're not great at all. They're always biased towards something. So just something to keep in mind. Not trying to start a political conversation. Just throwing that out there. Statistically speaking, polls are not good. Okay, so different types of sampling distribution. So there's a bunch of different types of sampling distribution. Kind of sorry that this one's a little bit hard to read, but at the same time, it's got a lot of good, useful information. So, how do we eliminate bias? There are different methods to do this. The first and probably the most easiest way of doing something is called a simple random sample. That's also the one that if you're taking Algebra 1, the one they want you to do pretty much all the time on. It's not the only one, but it is what it is. You're going to assign a population a number and pick people at random. That's pretty much it. You just give everyone a number, you pick them at random. So example, let's say a principal wants to determine the effectiveness of a new policy. He wants to do this by polling their students in their school. Out of a school with 3,000 students, the principal assigns a number to all the students and picks 600 students using a random number generator. That is a simple random sample. Very simple. Everything's at random. Everything's picked at random. You might do it just by picking numbers out of a hat, something like that. It's very simple, very easy. Then we have what's called a systematic random sample. It's similar to an SRS, which is the abbreviation to simple random sample, and you will see a ton of people just refer to it as that. So whenever you see SRS, it's simple random sample. So keep that in mind. And everyone in a population is still assigned a number, but instead of picking people at random, you pick people by some system. So like every 5, every 10, something like that. It's very systematic. So let's say that a principal wants to determine the effectiveness of a new policy. He wants to do this by polling their students in their school. Out of a school with 3,000 students, the principal assigns a number to all the students and picks students in intervals of 5. That is systematic. He's systematically picking in intervals of 5. Stratified random sample. Divide the population into different groups of like characteristics and then randomly pick people from each group. So these next two are kind of very similar to each other. I just read off the stratified. I'll read the cluster one in a second. They're really, really, really easy to make to replace one with the other. But let's look at this one. So the stratified would work like this. Let's say that a principal wants to determine the effectiveness of a new policy. He wants to do this by polling their students in the school. The principal is a high school principal, so they separate the students into 9th, 10th, 11th, and 12th grades, and then picks 125 people in each group at random. Now, the reason why this is stratified is because theoretically, you would have similar percentages of different people in each grade. So, like you would have a similar percentage of males in 9th, 10th, 11th, and 12th. You have a similar percentage of females in 9th, 10th, 11th, 12th. You might have a similar percentage of African Americans in 9th, 10th, 11th, 12th, and a similar amount of Caucasians, similar percentage of Latinos, similar percentage of Asian. That all should be fairly similar. Now, that's not always true, but really, for the most part, it should be. So that's what it means to be stratified. You break them into groups that have very similar digraphics in each set. Then you have what's called a cluster random sample. Your stratified sample will rely on groups having similar characteristics. Clusters assume that they might not. So stratified, they're going to have similar characteristics in each group. Cluster, not so much. So we break the population into different unlike groups and take random samples. So let's say that the principal wants to determine the effectiveness of a new policy. He wants to do this by polling their students in the school. They side us with the students in social groups like jock, overachievers, etc., and taking an equal amount from each social group. The reason why this is a cluster is because you're probably not gonna have the same percentage of like males in the jocks and the overachievers and stuff like and other social groups like that. You may not, but it's far more likely to not have like mannered groups than with the ninth, 10th, 11th, and 12th grade. Which one's the best? Neither one of them is any better than the other. They all have their flaws, but they're all just different versions of kind of the same thing. So let's label the following sampling distributions. So I have one of each here. You can pause the tape and read them over, but I'll go through it now. The city council is trying to get the opinion of its constituents on the new law. They decide to pick 20 locations in the city, such as Canton, Fells Point, etc., and take a random sample of 200 people. And if you know where those places are, you can kind of figure out where I'm located. Might have slightly doxed myself, but that's okay. So, because you don't know quite where I'm at. But what kind of sample is this? This is a cluster. Basically, anytime you use geolocations into anything, it's a cluster sample because geolocations aren't going to necessarily have people who have similar like interest in each one. So like the people of Canton may not be the same as the people of Fells Point, and they're probably certainly not the same as people in Hamburg where all the Huns are hanging out. So it's gonna be you don't have each geographic location is not going to be very similar. You can think of this like if you broke the world down to like Mexico, the United States, Russia, and Canada as a cluster, because they're certainly not going to have a similar grouping of people in each of those countries. So geography is usually very, very, very cluster. A company is attempting to determine the quality of the customer service. They decide to give a survey to every third customer that enters the building. That is systematic. We're going to third customer, so we have a systematic random sample. A business is trying to create a new employee incentive program to increase sales, and they want the opinion of their employee to determine which incentive program is better. Of the 500 employees, the company assigns each one a number and picks 100 employees at random to take a survey. So this is purely a simple random sample. He gives everyone a number and picks them all at random. We'll talk about how 100 employees is probably a little bit too big for this particular sample later, but for right now, that's definitely a simple random sample. A college professor is conducting a survey for next year's term. They decide to split the college into male and female groups and take 200 students in each group. This would be, by process of elimination, it's stratified, but it's stratified because he's literally changing them into two separate groups. So that's my examples. Then just two very bad sampling methods. Volunteer sampling based on volunteers. That's based off the fact that the voluntary bias of having people come to volunteers is the same reason that you don't want that. Convenience sampling, picking people who are close to you and are easy to convince because you basically just drive them to what you want anyway.